The reporter accepts challenge.
Okay, the reporter accepts the challenge of problem number 6. Okay, now the preparation of reporter is each write down the representative name on the blackboard. Okay, presentation of the reporter. So
Uncle Chris and fellow combatants, this is the reporter from Team South here. Today we are going to report the problem statement dripping faucet. This is the problem statement. A leaking faucet develop an interesting dripping patterns where the tube between droplets depends on the water flow rate. Investigate this phenomenon and study how it depends on relevant parameters. We mainly focus on two questions. The first one is, what are the interesting patterns of the phenomenon? And the second one is, how will the phenomenon change with the different flow rate? This is our outline. First, we are going to talk about a preliminary experiment. Next is the theoretical model. Third is experiment. The last one is conclusion. First, let's talk about preliminary experiment. Here is our equipment. We use the water faucet and a measuring cylinder to measure the flow rate, and we use the laser pointer and also the power supply unit and the laser sensor and Arduino board. And this is our experimental setup. First of all, we will turn on the water faucet to a specific dripping, and we will use the light sensor and the Arduino board to capture the dripping, and we use the measuring cylinder to measure the flow rate. And you might wonder that how do we use the laser point to capture the dripping? Because we put the light sensor between the laser line. So if the laser line passes through the droplet, the sensor can sense the droplet. And if there's no droplet, the sensor will not capture the droplet. And here is our theoretical model. We use Young's Laplace equation to describe the phenomenon. And the P means the pressure difference between the inside and outside interface, and the R is the surface tension, and the capital R is the radius of the curvature, and the radius of R is the water droplet, and theta is the tangent angle, and P0 means the initial pressure differential, and C means the vertical height. And we use the formula to simulate our shape of our droplets. So we can use the code to calculate the flow rate and to measure that. And under what condition is the time interval? Next is our experiment. This is the first part, is the stable pattern. We found that all of the data in this kind of condition is matched to one line. It means they are all the same. They are all in the same time interval. And what is because that it is very stable. And you may find that the theory line is higher than our experimental data. It is because in our condition we consider the time interval is in a very stable condition. But however, in the relaxed T, the faucet is keep pouring the water in the faucet, so the dripping will be more. The time interval will be more smaller. Next, we're going to describe the shape of our dripping. And because the radius of the sphere is roughly equal to the faucet radius, and in the next time, the surface tension can hold the mass of the droplet, so it will eventually separate into the upper side. Next is our second experiment, tube bifurcated. In our experiment, we found out that in the first part, the dripping will bifurcate into two time intervals. It is because that the high flow rate causes the water droplet to form a neck, and the next time the droplets break, the neck form a cone above, and the cone from a droplet, and then the process straight again, such as this video. And later, the if the flow rate increase, we found that there are more irregular patterns in our experiment. It is because that the higher flow rate causes the water droplet to form along the neck. The droplet break at the neck and form a long cone above. And the cone from 3 more water droplets, and then the process starts again. It will cause this phenomenon. And we can see there are 4 droplets in one circle. And the third part is chaotic. We found that in this part, in our experiment, our data is very irregular. And we can explain that is because the cone between the water field is different sizes. Because in this time, the water is become per size, and there is a cone above it. And in the next side, the water is continue pouring the water in the dripping. So it will have a lot of droplets to drop. And to compare our experiment with the reference kit, we found that in our experiment our data is very irregular, but in the reference kit, his data is chaos. But there are some ways to find out and to predict. And we found that it is because the chaos behavior is very sensitive to the initial conditions. We can only generate the stable pattern, the 2 buffer rate patterns, and to modify this situation, we use the communicating pipe to control the flow rate. But we found that the radius of the burret is very small, so the surface tension is very big. So the phenomena will only happen in the drift, and next is another drift. It will not have a cone on the top of the faucet. And this is our observation video of the buffet. Because the smaller diameters, the higher surface tension, and the dripping pattern, it is very stable. It won't occur the water column. And next, and you might ask me why we won't use the normal faucet to do the experiment. It is because that when the normal faucet and the diameter of the normal faucet is much bigger than the dripping and the diameter of the drip. So in this situation, the points of the droplets will very unpredictable. So we can hardly analyze this. Thank you. Sorry. There are some conclusions. The flow rate in our experiments, we found that if the flow rate increase, we can tell there are three different situations. And the first situation is stable pattern, and the next one is 2 buffer case. In 2 buffer case, we can separate it in. The first one is 2 time interval in 1 circle. The next one is 4 time interval in 1 circle. And the third situation is chaos behavior. Thank you.
Okay, thank you. So the question of opponent to the reporter.
Okay, so I would like to ask you, do you come to a converter during your experiments?
No, but we can sure that the temperature is almost the same.
Do you come
After our experiment, we used the measure splitter, and we used the
When you calculate
the
the total amount of the water.
and divided by the time.
Do you do the experiment for many times or just one time?
For many times.
Is the result always the same?
If it is in a stable situation, it's the same. But if it is in a chaos situation, it won't be the same.
What do you think is the main reason to cause chaos in this experiment?
Main reason. It is because the chaos mean is very sensitive to the initial conditions. So because our flow rates are very hard to control it, so the average droplet may influence the next droplet.
Okay, it's not like that. It's not what I mean by the result. What is the definition of chaos in the experiment?
It's very sensitive to the initial conditions.
I mean, how do you know it's chaos from your experience?
Because
Okay. Do you think there is really an exact value to distinguish whether it's chaos or not chaos?
it is depend on the flow rate.
Thank
and the diameter of the
you. Liberation of the opponent, 3 minutes. Okay, opponent take the floor.
Okay, hello everyone, I'm Jenna from Team Andromeda. Today I'm going to oppose problem number 6, dripping faucets. And here is the problem statement. So our main focus is how chaos reflects in this experiment. And number 2 is the interesting pattern mentioned in the problem statement. So first of all, let's talk about the review of the report. In his presentation in the theoretical model, he mentioned the gas and the formula of forming a droplet, and also put the Young's-Laplace equation. And for his prose, I think it clearly he has clear explanation of the form of a droplet. But I think viscosity is a really important factor to affect the dripping of the droplet. So I think we need to consider it. And also, he didn't mention why will there be gas and the definition. Like he just said that different flow rates will cause gas, but why different flow rate will cause gas? We don't know. So maybe I will discuss with him later. So in the experiment itself, it has done the water flow rate and stable into the private rates. For this case, I think he has good methods to support the experiment, like use the use the surface. And for this comes, he used the light sensor might cause the observation to make stabilized drop. Stabilized drop means the droplet that decides the primary drop. And also, the process used in the setup will cause water pressure unstable because the main theory in this experiment is gas, and gas is really sensitive to initial conditions. So I think the not accurate will have a really big impact in this experiment. And he also didn't control the flow rate really accurate. And for data analysis, he did a time interval and he compared different pattern of droplets. Also demonstrated time interval well. I think he did a lot of data points, which is I think is really sufficient to analyze the phenomenon. And for response, I think he didn't have the critical value of gas because in his graph, I just saw like 3 different parts of the time interval, but I didn't know that if there is really a critical value. And he only used one experiment to explain gas is that I have asked the reporter that what is the definition of gas, and the reporter asked that gas is really sensitive to initial conditions. So I think we need to do 2 times the experiment to prove that if it's really a little change will cause gas. And next is the discussion point. So in the theoretical model, I want to discuss the definition of gas and how can it connect with the data. And number 2 is to clarify whether the boundary between the gas and not gas is really an exact value or is a range. In the experiment setup, I want to discuss the accuracy of the setup, just as I have mentioned that gas is really sensitive to the initial condition. So if the setup is not accurate, we can know if it's really if the result is really just like the report said. And for the data analysis, I want to discuss what caused gas in the experiment and how the vibration takes effect in the experiment. So now I would like to invite the reporter to discuss.
Okay, discussion with the reporter.
So first of all, since we didn't mention how the droplet will form, so can you please write the force analysis on the board that we can have a better investigation?
This is the process.
Yes.
And the first you will have a sphere shape. And this is the mass of the droplet. And because the first is very stable, so you will need a surface tension to hold the droplets.
And just add the viscosity. And viscosity, which we did now, is also go upward, right?
Yes.
And can you tell me when will the droplet form?
When will the droplet form? It depends on the flow rate. If the flow rate is high, it will fall very quickly. But if the flow rate is very low, it will fall very long. It will fall for very long time.
Oh, so it means that if the droplet accumulate more in a single time, then it will fall very quickly. Is that what you mean?
No, I mean is that if the water falls very quickly, the droplet will fall very quickly.
Yeah, why will the drop fall very quickly?
Because there are some critical conditions for the shape of the droplet. If
What is the
and it depends on the surface tension and
the temperature, right?
Yes, but I can assure that it is almost the same.
But almost the same, because the temperature will affect the surface tension. You know that? Yes, and the surface tension will furthermore affect the drop of the droplet, right?
Yes.
And if the and you said that gas is really sensitive to the initial condition. So if there is a little change, then the result will be not the same. So I think that's a really important point for you to consider it.
We do the experiment in a laboratory, so the temperature is controlled very serious.
Okay, that's fine. So I have saw that in your experiment, you just use the faucet in your laboratory, right?
Yes.
But you know that it is not accurate because the water pressure will change. And if the pressure of the water change, it will cause a flow rate change.
But we try to control the flow rate. We use the fluid and the and the normal faucet. But we still can't. We still can't get the number that I want. So we use the faucet in the laboratory. It is a best way.
Best way. So
Better than the perfect and the normal faucet.
okay, so do you think if you change the faucet, the gas condition will change?
Condition the flow rate that will cause gas conditions.
Yes, will change.
Yes.
Okay, please turn to page 12.
Yes, sir.
Yes. I want to ensure again, do you think there is a critical value between gas and non-gas?
It is depend on the flow rate and the diameter of the faucet.
I mean that you draw a line between, like this is non-gas and this is other case and this is gas. So you draw a line between that. So do you think there's really a critical value? Because you just do like this data point, but here we can cut it into many small pieces to investigate how the flow rate will increase, how the flow rate will affect the result. So here you don't have the data point, so how do you know that the critical value is just right here?
Because we didn't do the all flow rates, so we can roughly separate to the three points. So actually we didn't find the critical condition for the chaos.
So think
It was between these two points.
so how do you know it will be this? Then maybe you should do more experiments to investigate that.
Yes.
Okay. I've asked that. What do you think is the reason to cause gas in this experiment? And the short question right? And you say that it's the flow rate.
Yes.
Yes. And why will the flow rate increase and the gas increase? Can you explain it to me?
Why the flow rate will influence the chaos?
Yes.
Because if the flow rate is higher, the water will pour very quickly, and the droplets will form very quickly. So it will form very little droplets to get the surface energy shoot.
So that's energy short.
Yes.
But I think it's because of the vibration. Do you observe the vibration in your experiment?
We didn't observe vibration because we didn't think that the vibration is very important.
Because there must be vibration in your experiment because if the droplet fall, then it's just like the model of a spring that if the droplet was to fall, and which means that the gravity will be bigger than the combination of viscosity and surface tension, right?
Yes.
Yes, and after the droplet fall, then it will not just stay at the same point. It will go back to the initial And
Well,
because, yes, so it will, so there is vibration.
Can you define what is vibration? Oh, well, I understand your point. Can you explain?
How do you know that if the flow rate increases, the capacity will also increase?
Because we do our experiments to found that the flow rate increase, the gas will become gas. Because it is different to the reference case, the map of the reference case.
Okay, I want to explain my opinion. I think it's because that if the flow rate increases, then if the flow rate is low, then after the droplet fall, the vibration would have time to go back to its initial position and then go to the second drop. Because if the flow rate increased, which means that the vibration didn't disappear, but the droplet just falls, so it would like go on gas pattern. Do you agree with that?
Yes, but I also mentioned that way because if the water flow very quickly, the vibration will damping more not that long. So the situation will very.
Why do you think that if the flow rate increases, the vibration won't last long?
Because the water flow very quickly, so it will become a droplet very quickly, and it will drop. It will not be a
Vibration is always the same.
vibration.
The vibration is always the same. Okay, that's fine. Can you please turn to the bifurcation page? Whatever page. Okay, last page. I mean, it's the page that you talked about. This area. Yes.
Yeah.
Oh yeah. Can you explain why there are two drops? Can you explain why there is a bifurcate? Why isn't there just a single period?
A single period. It's just like you mentioned that if the flow rate is increased, the vibration, it will cause the less vibration, and it will increase the next droplet in that time.
Can you explain that?
Because in our experiment, we observed that in a higher flow rate, the vibration will become slower, right?
Yes.
And it will.
No.
Thank you. People can summarize the discussion.
Okay, so in the discussing time, we have talked about the last definition of it is experiment. The reporter didn't just define what is gas in this experiment. I think if the result is gas, which means that in the same flow rate, there will be a more different period in the same flow rate. But if the flow rate is low, which means that it will just cause one period because just as I have said, the droplet drop and it will cause vibration. And if the flow rate is low, that the vibration will just quickly go back to its initial position. But if the flow rate is high, then there is no time for the droplet to wait for the vibration like that. And in this experiment, I think the
Thank you.
Okay.
Now the reviewer. Ask a question to the reporter and opponent. Please.
From the very low too. And first, I want to ask the reporter that for data in frame 3, how the experiment is not error bar but is chaos. Because if they
scale, it used the return map to say that it's very chaos, but there are also some interesting kind of stuff. But our graph is different to the reference case graph, so we can define that.
Thank you. So I want to ask the second question to report the last. Because you mentioned that the droplet will strip, and when the light sensor reflects back to the light is, you will, and which part of the droplet is reflect back? Because you say that your droplet will strip when it doesn't fall from the droplet. So when the light sensor reflects back to the light, which part is the what part of the droplet is reflected by?
All part of the graph.
But you say it will stretch, so
Stretch. That's why they use stretch.
when the okay, thank you for that. And the next question is, do you control the water pressure?
No, because the water pressure will influence the flow rate. So we measure the flow rate, then we don't have to control the water pressure.
Okay, so and I want to ask the reporter and the opponent that what reason do you think that the previous drop gives the impact to the next drop?
I think it's the vibration.
Okay, and
I think it's the flow rate.
okay, so that's okay.
Thank you. Now preparation of the reviewer. 2 minutes. The reviewer take the floor.
Yeah, I'm going to run on the round. Here's the first thing. Political system matters when current drop signal on the vertical rate. So in this case, the current signal on the railroad carriage.
Excuse me, could you speak louder? The one jury could not hear you clear.
Here's the overview. The theory is the young place depression and the formula of forming droplets and the chaotic behavior. And the experiment they use the light sensor and the stable pattern, and it parts to 3 parts. The one is the stable pattern, and the number 2 is 2 bifurcation, and number 3 is chaotic. Okay, here's the discussion. manually separate. But we think that they can do more experiments to make more data to found the back boundary. And the next is how flow rate scales. And the first thing, it will drop quickly. And
Okay, thank you.
Okay, thank you.
Now the concluding remarks of the reporter.
About pattern behavior definition, when the dripping pattern or the flow rate is unstable or irregular, we define any static behavior. So it is not related to the temperature. And about the measurement, our laser sensor has an extremely accuracy, and the laser sensor won't miss or has any data delay. And about the temperature distance and influencing factor, we conduct our experiments in an environment in which the temperature won't change significantly. And about the viscosity is not an influencing factor. And about the accuracy, we conducted experiments to ensure it fits our theory. And that's our conclusion remark.
Okay, thank you. Now the question from the jury. Any questions from a jury?
Because I when I was a kid, I played that there is something called water clock. The water clock. So water clock means that you have a drop. So you feel your container, then it should be, you can count the time. But in this experiment, you are talking about the chaos. So I want to ask, so can we still use this water bottle to count the water clock?
To use this setup to be time counting. Do you understand the question from the jury? Do we use this forcing reading to design a time counting device?
I think if the flow rate is low, because if the flow rate is low, which means that the time interval will be the same. So I think in this case we can use it to do the water clock. But if the flow rate is high, just as I have mentioned, is gas. And this is vibration. So in the high flow rates, the vibration will further affect the next drop. So I think the time interval will not be regular, so we cannot use this.
How about the opinion for the reporter?
Test will only happen in certain conditions. So if the water clock, right? So if the flow rate is very slow, it will be stable. So I think that it can use that kind of setup to use to the water clock.
How about reviewer, your opinion?
I think it is more well because I think it's regular in the first pattern, so it can the word can depend on the first phrase, but in the second and third phrase there are more irregular in time interval. So I think that it can't use on these two phrases.
Okay, no question from me. So please have a seat. Now it's grading. The grade for the reporter 6, 6, 6, 7, 7. Okay, correct. And the grade for the opponent 6, 8, 7, 8, 6. Correct. And the grade for the reviewer 6, 5, 7, 6, 5. Correct. Okay. So any comments from the jury? 再借各位1分钟好不好？各位老师还有同学都很辛苦了，给我那个谢。因为刚刚有同学问我要怎么表现得更好，因为时间真的很有限。各位同学，你们晚上吃完晚餐、盥洗完之后，如果还有时间呢，可以做一件小调整。第一个呢，你们的图形要很清楚，要像我的图那么清楚，纵坐标、横坐标、数据都要很清楚。然后你介绍的时候呢，我都没有看到一个同学说 vertical axis represent relative intensity and horizontal axis represent the Raman-ship， 你们都没有讲这些重要的资讯，所以我也看不清楚你们到底要呈现什么。那如果是2个图的话呢，还是一样要很清楚啊，对不对？清楚的呈现你的实验的图形，然后评审会非常感激。另外一个呢，你有没有看到我那个页码特别的大？我们要问你们问题，就怎么找那个页码是最快。那希望你明天有一些进步。我常常讲，各位同学，你们如果每天进步一点点，幸福快乐到永远。好，我们结束今天的，谢谢。